Hello everyone. This video will give you an overview of what OpScripts are and how you can use them. An OpScript is a powerful way of using Lua code to manipulate attributes and scene graph locations. When you use nodes in Katana, they are usually for a specific task. For example, the camera create node is for, creating cameras. But with an OpScript node, you can do pretty much anything to manipulate your scene. So you would normally use an OpScript if there isn't already a node in Katana that does what you need. Think of it as the Swiss Army knife of nodes. The OpScript node has several options, so I'll go through each of these with some simple code to demonstrate what happens. Now, to make an OpScript, you hit Tab in your node graph, and I'm going to filter my list of nodes here with OS. So that's using the camel case, O for op and S for script. I'm just going to add my node in, and I've double clicked it to view it and edit it. Now if we go over to the parameters tab, we can see the options. The first thing is cell statement. So whatever scene graph locations match this cell is where the code will run. Next we have our script section, and you can see here it's marked as Lua. And then you have your script box where you write your code. And just above that there's this button that says edit in external editor. So if you don't want to write your code in here and instead use your preferred editor, then you can click this button. To choose which editor you want to run, you can go to Edit, Preferences, and under External Tools, you set your editor. So in my case, I'm going to be using Sublime. And then you just click this button and it will load up your external editor, create a temporary file, and you type in here your code, you save it, and then it will go transfer back into the text box. Once you're finished, you can click this button. Now it reactivates this and you can type back in here. Okay, so let's get cracking. I've got a simple scene with a teapot that I've made with a primitive create node. So I'm going to take this teapot scene graph location, middle mouse click and drag over to my cell statement, and let's write some code. So the first thing I'm going to do is type in interface. Now the interface is your gateway to scene graph locations and attributes. There's lots of different functions that you can use. The first one we're going to do is for setting attributes, and that's set attribute. And this takes two arguments. The first is which attribute do you want to change, and the second one is what value do you want to give it. So the attribute we want to change is type. So we're going to put the string type in. And then for the value, we need to specify what type of attribute it is. Is it a string? Is it an integer, a float, or a double? For this case, it's a string. So we're going to just type in string attribute. And we're going to give it subd mesh. Okay. Now to run our code, I'm just going to click off of the box and it's going to run that. And it's changed to subd mesh. So if we view our teapot at this point, it's polymesh. You can see here. And then we now view our OpScript and our teapot is nice and smooth and it's changed to subd mesh. Okay. Now if we were to look at some attributes, if you hover over in your attributes tab, it will tell you the attribute type. So this is a group, and then this exclusive to is a string. And then for example, if we go into a geometry, point P is a float, and then xform information, an xform value for translate is a double. Just to give you some examples of different attribute types and how you can see what they are. It's important that when you set an attribute that you set it with the right type. Okay, so now we've set it to subd mesh. What about if we wanted to have it so that we could choose? What we can do is we can add some user parameters that gives you this option. I'm just going to hit spacebar here so we can just look at our OpScript. And right in the top right hand corner, there's this wrench, and I'm going to click that and do edit user parameters. Now this adds an option down at the bottom here. I'm going to add string, and I'm going to rename the parameter to mesh type. Okay. And then I'm going to use the widget type of pop-up menu, and then use the widget options to add my options in. So poly mesh, and add another one, sub D mesh. Great. And now I'm going to click on this wrench again and say finish editing user parameters. Now I've got my poly mesh and sub D mesh here. Okay, so how do we access this? Well, there's another interface command that we can use. So I'm just going to bring this down, type interface again. Now we're going to use get op arg, and we're going to give it user.mesh type. Okay. Now all user parameters you add here will get converted to these operator arguments. And then you can access them with this get op arg, and then you give it the path, so user dot and then whatever your parameter is called. Now we want to take the result of this and store it in a variable. So in front of that, we're going to type in local and the name of your variable, so mesh type equals. Now it's good practice whenever you make a variable in Lua to specify if it's a local variable or global. Now that we've saved our result here into this variable of mesh type, you can take mesh type and replace it here. Now we don't need to say if it's a string attribute, because what gets returned here is the actual attribute. So it's going to bring that attribute mesh type, and it's going to be a string attribute with this value enclosed. Okay. So now we've still got it as a sub D mesh, and then if we change this in the options, it will change it to poly mesh. Okay. So let's now look at some of the options we've got in our OpScript. So the first thing is execution mode, and it's set to immediate. And as we saw, it immediately ran and changed things. But what we can do is set it from immediate to deferred. Now, when we do that, what happens is it stays as poly mesh, and under our attributes, it adds our OpScript as part of this ops group. And now, whatever your node is called is what it would be called here. So I'm just going to change this to os_mesh type. Here we see os_mesh type. And then it has the op args, which has our script and our user mesh type. So that's where this op arg comes from. Okay. Now, if we want to run this now, we can do an OpResolve. And then if we view this node, it's changing it to sub D mesh. And what happens is our code now goes from an ops section into an info section. Now we've got info just to show what ops have now been run. And there is our op. Okay. Now, if you don't have an OpResolve node in your node graph, instead what will happen is your script will run at render time. So what we can do is if we view this node, we can simulate what will be run at render time by turning on implicit resolvers. To do that, you use this clapper icon that you can see in the scene graph area. It's also on the top menu, and it's also here in attributes tab. So when you turn this on, you're going to run the code and change it to sub D mesh. This allows you to see the final result. So you can defer heavy scripts so they don't run when you're working, but then they get run at render time. But if you want to see the result, you can turn on implicit resolvers. Okay. And also, once you turn on this implicit resolvers button, you'll see that this warning comes up saying implicit resolvers are active. And if you click this, it's now going to load up all of the ops that will get resolved when it gets turned on. I'll talk a little bit more about what this means later. Okay. So if we just scroll down a little bit, you can see, as well as specifying if it's deferred, you can now say when it gets deferred. So during OpResolve, so when you have an OpResolve node, or when the implicit resolver runs, or you can change it to material resolve. If we change it to that, what's going to happen is our op is now going to live in the material section of your attributes. Let's just turn off our implicit resolver. So you can see it there, there's our op. And then the third option here is instead of material resolve, you can have it resolve for look files. So when we do that, it goes back to being in the ops section. But if you scroll down, you see it's added another attribute called resolve IDs, and it's giving it two IDs, look file resolve and implicit preprocess. And I'll talk about these IDs in a minute. Okay. The next option we have is modifier name mode, and it's currently set to node name. So that's what's been stored here. And we can change this to, instead of node name, to specified. Now, the reason why you want to do that is, say for example, make a tool that uses OpScripts, and it's used quite a lot in your scene. You'll end up with a stack of OpScripts, because every time you make a node, it can't be with the same name. So you'll get a unique node and you'll get a unique OpScript in your list. So now I have my OS mesh type and I have OS mesh type 1. But if I were to change this, instead of using the node name to specified, we now give it mesh type as a name. I'm going to copy that, place it in here. So specified and mesh type. Okay, now it's got ops mesh type. And for example, if I view here and have it set as polymesh, we'll be able to see under our user arguments, mesh type polymesh, and then we view here and it's just changing this bit to subdmesh. So this obviously means that you're not stacking up lots of ops, you're just changing that one op as you go through your scene, which could be a much more desired result. Okay. So let's just change this back to OpResolve and change this back to node name. And let's talk about this resolve IDs option. Just going to remove the second op as well. So this resolve ID, you can give it a specific ID name. So let's call it, say for example, mesh type. Now if we go back to our OpResolve node, you'll see there's an option here. It says resolve with IDs all. And we can change this to specified. If we do that and we go to our OpResolve, it's still going to run our code. Let's change this to subdmesh, and now it's going to resolve that. And that's because when it's blank, it'll still resolve all IDs. But if we give it a name, just anything like hello, you'll see our code does not get run. It's staying as polymesh. But if we give it the ID that we said of mesh type, enter, now it's going to run our code. That means that we can have it so that only ops that we want get run. You might have a lot of ops in your scene, but you might want to just target one to run at that specific point. So that's a really handy little trick. This is also can have more than one ID, and you can do comma delimited. So this will now do anything that has mesh type as an ID and also hello as an ID. Okay. So next one is recursive enable. So normally when you have an OpScript, you'll want to run it at several locations or set up wildcards. But there might be occasions where you want to run it across all scene graph locations that live under a certain point. You might even want to run it literally from root all the way through your entire scene. Now you can, in your cell statement, change it to a custom cell, so custom, and say do something like // star, and that's going to run through everything. and now it's changing all of the types to sub-d-mesh on every SINGRAPH location. But a more efficient way is by setting it at, say, for example, root, and then turning on recursive here. And now that's going to run through all of my locations and change them to sub-d-mesh. Now, if you use recursive instead of using a cell statement with // this will run a bit faster. It also has an option to disable at any point. So, for example, I could give it this geometry location, and it's going to run on root weld and then stop at geometry, or I could give it the teapot location. Now it's going to run along all of them until it gets to the teapot, and it won't run there. Okay. And then right at the bottom here, we have the last option of multiple sample user op-args. So every time you have an attribute, you can have more than one sample. For example, a good one is points. What you normally do is you have, say for example, 3 samples for a point. So you'd have your middle value at 0, and you would have a value of minus 0.25 and a value of 0.25, so you can do motion blur. But for the most part, I would say your user attributes or your user arguments are not going to have multiple samples, but if you did, then make sure this is a yes, so you can read all those values. Okay. And then if we change it back from deferred to immediate, we get some other options as well for when the code runs immediately. The first thing is apply where, so at locations matching cell. The next one is at all locations. So this is now going to run across everything and change everything to sub-d-mesh. And then the last one is at a specific location. Now, the important thing to remember if you set it to at specific location is if this location doesn't exist, so I'll put root weld location, it will create it and then run the script on that. Okay, and then the last thing is this input behavior, so by index. So what does this mean? Well, you can actually have more than one input to an OpScript, and you turn this on and it adds this little option here, and you click that button and you can add inputs to it. So why might you want to do that? Well, let's write some more code at a different area over here. So I'm going to give you an example. I've got an alembic in here that's bringing in some locators that I've made from Maya. But what happens is they just come in with a group, and that's it. And then the location is set by some xforms with some translations. I can't see this in Katana. So what could I do? Well, one thing I could do is write an OpScript. So let's do that. Okay. And I'm going to pick all these locators. So I'm going to do custom. And do a / star locator shape star. Okay. Let's just test to see that that's grabbing our locators. Yes. Okay. And what I want to do is have multiple inputs. And I'm going to start off with 2. I'm going to connect in our locators here on input 0. And in input 1, what I've done is I've made an actual locator in Katana using the type of locator. And I put it in the location of root weld geo locator. And what I can do is write an OpScript that's going to take the geometry information and the type from our original locator and put it on all of our locators that we've got from Maya. Okay. So again, we're going to do the interface. And now we're going to use copy attribute. And we're going to say we want to copy geometry from geometry. And then you need to say if you want this attribute to be inherited or not. It doesn't matter in this case, so I'm going to say false. And then from what location are you copying it from? So this is root world geo locator. And then the last thing is what input is it coming from? So this is input 1. Okay. And we want to do exactly the same thing, but for the type. So I'm just going to copy and paste this and change it to type. Okay. And that has changed our locators to be locators and give them geometry. So if we click on one, it now has some geometry. And if I just click on the top thing here, you can see our locators now. That's pretty good. Now, another thing you can do is this input behavior by index. What does this mean? Well, it just means that whatever input is in here is also going to be the same for the OpScript. There's another option here that says only valid. Okay, and I'm going to change that. And I'm going to add another input here. And I'm going to change this to input 2. Now, because input 1 hasn't got anything connected, it's going to default to input 1 is this one. So this means that you can use something a little bit sneaky, and it's kind of going to act like a switch. So currently my locators are getting this input and getting the geometry from this and the type from this. But now if I were to connect something into here, this would now become input 1. And instead of getting the information from here, it's going to get it from here. What I've done is I've made a sphere, a primitive create sphere, and I connect this in. Now it's changed into spheres. So if you think about that, you could have a tool, and this could be your fallback. So if we were to let's move this up a little bit and this up a bit, we could. Actually, I'll connect this again still, and then I'm going to group it with G. And this could be our little node that does something, and we have a little input here. So we have, oh, this default is going to be our locators. But if you do want to connect something in, then it will change it to be whatever that is. And now it's changing it to spheres. Oh, just to note, I've made the sphere exactly the same location. So root world geolocator. So that's something to bear in mind when you're doing your code. It's looking for the same one. Okay, that's an interesting thing to think about when writing your OpScripts. Okay, the next thing I want to talk about is when we turn implicit resolvers on. So when we do this, it had a list of these resolve IDs, and it said you've got an OpResolve that has an ID of implicit preprocess or look file resolve, and you've got one at the bottom right here that's resolve ID of all. So these ops will all get run in an order, and you might want to make sure your OpScript runs at a certain point. So you might be like, I want to make sure my OpScript's deferred, but it runs before these ops. Or I want to make sure that my OpScript runs after another op that is set to implicit preprocess. So let me give you an example of that. So I've got a viewer objects settings for my teapot, and I'm setting it on my teapot to turn it green. And then I've got 2 ops above it. One is to do the same thing with a set attribute and turn it to be red, and then another one to turn it to blue. They're both set to deferred, and they don't have any resolve ID. So when we turn on implicit resolvers, it's going to set it to blue because it's lower down in the stack. I'll turn that on, and now it's blue. But if I were to give blue a resolve ID of implicit pre-process. Okay, and then turn on my implicit resolvers. It's now going to be red because this will get run first and this second. So this gives you a way of being able to control the order of your ops by using these resolve IDs. And this will be really important if you know that you've got something that's already set up in your scene that's going to run at a certain point, and you either want to make sure that your op that you've written always runs before that or after it, because they might, for example, that might change a value and then you might want to come in after that and change it again. So that's just something to bear in mind when you're writing a lot of deferred ops, is thinking about what order you want to make sure they run in. Okay, hope that's been helpful. Gone over a few little concepts for OpScripts and should hopefully get your mind thinking about what you can do.